All right, so this is Unit 2, Operations with Polynomials. The question here says, how do you add and subtract polynomials? And you've heard this before. You add and subtract polynomials by combining like terms. And definition of like terms is that they have the same variables and same exponents. So when you get to your examples, it says simplify each expression. We're going to simplify this by combining like terms. One thing you really have to look out for on all three of these problems is that there's a sign in the middle. You don't have to circle these. Okay? So don't attempt to box or FOIL these, meaning don't attempt to multiply these problems. I see it every year. People are tempted, because they see the parentheses, they're tempted to start boxing or foiling or multiplying right away. But math is like language, so you have to read it carefully. The plus sign in between these two sets of parentheses just means that we're going to be adding, okay? So you don't have to circle or underline that, but I wanted to point that out. And actually, with problems such as this one on number 1, you have this set of parentheses, x squared minus 2x, and we're adding it to this set of parentheses, 3x squared plus 8x minus 5. So going by the order of operations, you look inside of the parentheses to see if there's any like terms inside, and there aren't. So we can actually drop the parentheses now since there's no multiplication. And I'm just going to rewrite this problem as x squared minus 2x plus 3x squared plus 8x minus 5. Now we're ready to combine like terms. So let's start with the first term on the left, and I'm going to identify them with a different color. You can borrow colored pencils from me if you want to do this. The first term is x squared. Is negative 2x a like term? No, it's not. While they both have x's, negative 2x doesn't have the exponent of 2. Okay, its exponent is 1 when you don't see it. So negative 2x isn't a like term. How about 3x squared? Most certainly is a like term. So we have x squared and 3x squared. Then we have 8x. That falls into the same category as the negative 2x. And then we have negative 5, which is a constant. So first, let's add x squared and 3x squared. Remember, there's a 1 right here if you don't see it. Okay, so 1x squared plus 3x squared is going to give us 4x squared. And we're done with the x squareds. If you want, you can cross them out. Okay, now we're going to move on to this negative 2x. And the most common mistake people make here probably is that they forget the negative sign. Okay, so whatever sign is to the left of your term goes with that term. So that's a negative 2x, and we're going to combine that with 8x. So negative 2x plus 8x. Again, we're just adding the coefficient, so negative 2 plus 8 gives us positive 6. And that means that negative 2x plus 8x would be positive 6x. So far, so good? Great. So we use those up. Then you have this lonely negative 5 over here. It doesn't have any like terms, so make sure you bring it down. And there's our answer, 4x squared plus 6x minus 5. In our next example, we have 4a plus 8 in parentheses minus a squared minus 6a in parentheses. So this minus sign is what we want to focus on here. This is a similar problem to the one that we just did. However, we have a minus sign instead of a plus sign. Minus signs are a little trickier than plus signs because plus signs don't really change anything, whereas a minus sign outside of parentheses is going to change whatever follows it. Okay? So this 4a plus 8 right here, we can write that again without parentheses. So that's going to be 4a plus 8. But this minus sign is going to change this set of parentheses. So it's like distributing a -1. So this is going to become minus a squared plus 6a. So what we just did was multiplied each of those terms inside of the parentheses by -1. That's what the negative sign does. All right, so now we don't have any parentheses anymore. We're ready to go ahead and combine like terms. So let's do what we did last time. You have 4a. Can we combine it with the 8? No. How about the -a squared? No. How about the 6a? Yes. So 4a plus 6a gives us 10a. 10a. We've used those, so you can cross those out if you like. And then you have plus 8. Are there any other constants? No, they're not, so you can write that. That's the only one, so we can cancel that out. And then you have minus a squared. It's all by itself, so just be sure to bring it down. So we've taken care of all of our like terms. We've brought everything down. This answer here is acceptable. I'd accept it, but on a multiple choice question, you're probably going to see it written in order from highest exponent to lowest exponent. So you might see it rewritten like this. Okay, this term has the highest exponent, so it's going to be negative a squared, and then we have plus 10a, and then we have plus 8. Oops, that's okay. So that's probably how you want to get used to writing your answers. Okay? Let us know if you have any questions. We'll try number 3. So again, number 3 has a negative outside of it. So again, be careful when you're reading this. And it's a -5. Okay? So we need to take care of that before anything else. Well, first you'd want to see if there are any like terms inside of the parentheses, which again, we don't have. So we need to take care of this -5, and we're going to do that by distributing. So this problem is pretty similar to the one above. So we're going to distribute this -5, meaning we're going to multiply -5 to the y squared, and we're going to multiply the -5 to the -8. So we can rewrite this problem now as 3y squared. So this set of parentheses is staying the same, except we're getting rid of the parentheses. So 3y squared minus y plus 1. And then we distribute it, which would give us -5y squared plus 40. So this right here gave us -5y squared plus 40. All right. So now we're going to go ahead and combine like terms. So let's start with 3y squared. What can I combine that with? -y, no. 1, no. Oh, -5y squared. All right, so again, it's important to make sure that you're paying attention to the term and the operation sign that comes before it. So 3y squared minus 5y squared is going to give you -2y squared. So we use that and that, get rid of them. And then you have negative y, and there aren't any other y's, so that's going to stay the same. And then you have 1 and 40. 1 plus 40 is 41. And that's going to be your answer. How do you multiply polynomials? You guys have done this before. Either by distributing or using what I like to call the box method. I can show you distributing if that's what you like, but in these notes I'm going to use the box method, or by using the box method. Here's what I mean by that. Notice problem number 4 and 5, they're different from the problems that we just did in that there's no sign between the parentheses here, right? We don't have a plus or minus sign there, so I was just trying to point that out. So we're multiplying, okay? So simplifying this problem means to multiply. You have a binomial, meaning there's 2 terms here, times a binomial, meaning there's 2 terms there. So to use the box method, what you're going to do is draw a square, and then you're going to have 4 smaller squares inside of it. The first binomial, x minus 3, we're going to put the x there and the minus 3 here. Again, pay close attention to the signs. And then the other one was 2x plus 5. So we're going to put the 2x here and the 5 here. It's a positive 5, so we don't really need to put that plus sign there. And now we're going to fill in the box like this. I'm going to take this x and multiply 2x, and I'm going to get, you don't have to underline those, but we're going to get 2x squared. And then we're going to take this x and multiply it to the 5, and that's going to be 5x. All right, now we're going to use this negative 3, and we're going to multiply that to the 2x, and we're going to get minus 6x. Now we're going to take this negative 3, and we're going to multiply it to the 5, and you're going to get negative 15. So you filled the box in. We have to write our answer out now. If you call my voice crack there, good for you. Okay, but we have to write our answer out now. So we did a nice job of filling the box in, but we still have to look for like terms. So like terms are usually going to be in the diagonal right here. The other boxes don't have any like terms. So we have 2x squared. Okay. The negative 6x plus 5x is what we're going to combine. You can write it out again if you want. And then you have that minus 15. Okay? When you combine your like terms, your answer will be 2x squared. This is going to give us minus x, and then the minus 15. That's your answer. Good work. All right, 1 minute to do the last one. So I'm going to set up the box. And since we have a binomial times a trinomial this time, the box looks a little different. It's more of a rectangle where you have 2 rows and 3 columns. So y plus 7, the binomial is going to go on the side. And the trinomial y squared plus 2y minus 5 goes on the top. And now we're going to fill in the box. So you can do this on your own, or you can watch me do it. Y times y squared is going to be y to the third. Okay, remember when you're multiplying and the bases are the same, the bases are that's the name for the big part, or the variable here. You add the exponents when you're multiplying. Okay, so let that sink in. Then y times 2y, now we're doing y times 2y, that's going to be 2y squared, or 2y to the second. And then y times negative 5 is going to be negative 5y.